In this video, we will be talking about inverse trig functions. So you may have seen them a lot in your trig classes. And it actually ties into what we were talking about before about inverses. So we kind of said that a function is one-to-one. So if a function is one-to-one, then you're going to have an inverse. And based on the inverse, we can basically, it's an easy way to find the domain and the range. So sine, cosine, and tangent also have inverses. So we just are going to denote them as y equals sine inverse. So even though there's a -1 there, it's not a power of a -1. It's just we would just say sine inverse of x, cosine inverse of x, tangent inverse of x. Usually these are also called arcsine. So instead of writing the inverse, it's just another fancy way to write sine inverse. We can just write an arcsine. We can just call this arc cosine. And we can also call this arctangent. Okay, so that's just another fancy way to talk about inverses. Now, what I have over here is basically the restrictions. So these are basically where the angles in which these are restricted to, or these inverses are restricted to get. So for example, if I were to look at the inverse sine, and we'll just look at the inverse sine for a second. So the inverse sine kind of looks like this. So we know that by graphing this, 0 pi over 2 pi, 3 pi over 2, 2 pi. So by doing that, we know that the graph of sine starts at 0, then at 1, then 0, -1, 0. So it looks kind of like this. Okay. Kind of like this. And we know that it's going to continue on this way as well. So now the thing is, if you look at the horizontal line test, you can see that this is not going to pass the horizontal line test. So this is not one-to-one. So what we got to do is kind of what we did with the parabola, which is restrict the domain. So one of the things that we did is that we kind of restricted this guy from -pi/2 and pi/2. So basically, all we are just getting is this little part of the sine curve. And we're going to say that this little part of the sine curve, so from -pi/2 to pi/2, so this little thing is going to be the sine wave. Okay, so this is just sine of x. Okay, so remember that in order to find the inverse of this, then you're going to take each x value and switch it with the y value. Okay, so the sine inverse is going to look like this. So now I'm switching my x's. So now these are going to be my x's. And then I'm switching my y. So now these guys are going to be my y's. Okay, so now you can see that all of them just kind of swapped places. So they're going to have the same exact points, but now it's going to look a little different. Look more like this. Okay, kind of like that. It's a little flatter though. Yeah, this will be the graph of the sine inverse. Now, you don't need to worry so much about the graphs. Do kind of know what they kind of look like. Maybe in the future, just keep them in mind. And then you can always just look them up and look at, oh, what does the sine inverse look like? What does the cosine inverse looks like? What does the tangent inverse looks like? There's also exist certain inverses for cosecant, secant, and cotangent, but we're not going to talk about them here. Just know that they exist. Basically, one of the good things about the inverses is that we can now find an angle. So for example, y equals sine of x. The input here is an angle, and the output here is a value. So when we look at the inverse of sine, now the input is going to be a value, and the output is going to be an angle. So you kind of swap everything. However, the only thing is because we are restricting these, the angles that these are going to give me are only going to be between -pi/2 and pi/2. So if you remember from the unit circle, in the unit circle, here it is. So the unit circle is only going to give me these values. These guys. Okay, because this is -pi/2 and this is pi/2. Okay, So when you do it in the calculator, you're gonna see if you have the TI-36, you're gonna see this word sine and then sine inverse. If you just press this twice, you're gonna be able to get the sine inverse of whatever that is. Okay, so let's go ahead and give you an example. We wanted to figure out what the sine, inverse sine of, I don't know, of 1/2 was. Okay, so let's say we wanted to figure out that. Now, one of the things that you can do is just put it in your calculator, and that was kind of cheating, but but one of the things that you can do is, okay, well, how is the calculator calculating this? So remember that the sine inverse has only restrictions between -pi/2 to pi/2. Okay, so it only gives you angles in quadrant 1 and in quadrant 4. So if we go to the unit circle and we look for the value of 1/2, so it's going to be this guy. Okay, so that one corresponds with what angle? Pi/6. And as you can see, it's on the interval. Okay, so this guy is going to be equal to pi/6. Now it's going to be really tricky when you start looking at negative values. So if you want to figure out the sine inverse, let me use arcsine since we know that that's the same. Let's say we want to find arcsine of -√2/2. Okay, so if you want to look at the arcsine of -√2/2, then let's go back to the unit circle. Remember that we are only in this restriction. So if I look at -√2/2, it's going to be right here. Now you have to be very careful because this is not 7 pi/4. That's a mistake. Remember that from here to here are going to be positive angles, and from here to here are going to be negative angles. So this guy is really -pi/6. This guy is really -pi/4. And this guy is -pi/3. So it's kind of like a mirror image, but they're negative because if we're going in the opposite direction. So at -√2/2, the answer will be -pi/4. Okay, and we can do that also with inverse cosine and inverse tangent. You just have to keep in mind these restrictions. So for example, this one is from 0 to pi. This one's going to be in quadrant 1 and in quadrant 2. This guy is going to be just like sine. It's going to be quadrant 1 and quadrant 4. So if I said, what is arctangent of 1? Let me just say -1. So if we're going to go to the unit circle, we're just going to look for the arctangent. So remember that the tangent is a sine over the cosine. And if it's 1 or -1, that means that the values have to be the same. So here you can see that both of these guys are the same. So here it's going to be 1. Here the numbers are going to be the same. So this one's going to be -1. So at -1, what am I going to get? Well, at -1 is going to be this -pi/4. So I'm going to write right here, whoops, -pi/4. And what about, whoops, cosine inverse of -√3/2? So what would that be equal to? So remember, cosine is between 0 to pi. So we're going to look at quadrant 1 and quadrant 2. So we're looking for -√2/2. So that one corresponds with this guy right there. And notice that one is going to be 5 pi/6. Okay. Okay, so pretty basic, something that you don't need to put into the calculator at all. But you can if you want to. So now let's do a couple of interesting ones. So let's say I wanted to figure out what was going to be the cosine of the tangent inverse of 3/4. So let's say we had something that looked like that. So clearly we can put this into our calculator. That shouldn't be too bad. The only thing that we want to be able to do though is, well, this one's going to be a little bit difficult to kind of figure out, right? Because you can kind of tell, if you put it in the calculator, it probably is going to give you a decimal, but really what I'm looking for is the exact answer. And if you kind of just think about how to do this by hand, well, let's think about the inside. So the inside, remember that this tangent inverse is just going to give me an angle. So I'm going to say that angle is going to be theta. Okay. So basically, I'm going to substitute this entire thing with theta. So this is going to be cosine of theta. Okay. So whatever that may be. I don't know what that is. So now theta was equal to this inside part, tangent inverse of 3/4. Okay. Now, in order to kind of get rid of this tangent inverse, I don't like working with tangent inverse. Tangent inverse is kind of difficult. So what we're going to do is we're going to apply a tangent to both sides. And basically, because these are inverses, these guys are going to go away. So I'm left with tangent theta is equal to 3/4. Okay. Now let's think about this. This we can write it as a triangle. Okay, as this triangle. Here's this angle theta. And then we can just do, well, that tangent is just the opposite over the adjacent. And we can figure out what the hypotenuse is. So that's going to be 4 squared plus 3 squared equals c squared. So 16 plus 9 gives me c squared. So c squared equals 25. So finally, c is going to be equal to 5. Okay, so now doing this whole thing makes me create a triangle that's going to make it easier for me to solve the original problem, because we said that this middle part was just theta. So all we just need to figure out, in order to know what this guy is, we just need to figure out what cosine of theta is. So let's look at our triangle. What is a cosine? Well, the cosine of theta is just going to be the adjacent over the hypotenuse. That's just going to be given to you as 4/5. And that's the answer. Okay. So now let's try this one. Let's say we wanted to do the tangent of arc sine of x over 2. So let's say we have something that had an x. Well, we're still going to do the same thing. So the first step is kind of let your inside usually going to have an inverse. That's how you know that you're going to let that be equal theta. So we're going to set the inside be equal to an angle. Let's say that's phi. Let's call it something different. So this is going to be tangent of phi, or phi. So now we know that phi equals arc sine of x over 2. And now we're going to get rid of that sine, or that arc sine, by taking a sine to both sides. So because they're inverses, they basically cancel each other out. So we have the sine phi equals x over 2. All right, and now let's go ahead and graph using a triangle. Let's use the right triangle trigonometry. So here's phi. Sine is the opposite over the hypotenuse. So now all we have to do is just do figure out what the a value. So it's going to be a squared plus b squared. In this case, it's going to be x squared equals c squared, which is going to be 2 squared. So we have a squared plus x squared equals 4. I'm going to subtract x squared to both sides. So a squared equals 4 minus x squared. And then we're going to take the square root to both sides. Okay, a is going to be equal to the square root of 4 minus x squared. So this guy is going to be the square root of 4 minus x squared. Alright, so now we can figure out what tangent phi is. Tangent is going to be the opposite over the hypotenuse. Opposite over adjacent. So that's going to be x over the square root of 4 minus x squared. And you can just leave it like this. You don't need to rationalize it if you don't want to. Okay? So that's how you do those types of problems. Okay? So we're going to do one last problem. Okay? So let's say a 65-foot ladder is along a wall 37 feet from the ground. Okay, find the angle of elevation from the ladder to the ground and round to 1 decimal. Okay. Have a 65-foot ladder. It's along this wall, and so the ladder is 37 feet from the ground. Okay, so find the angle of elevation from the ladder to the ground and round to one decimal. I think I misspelled elevation. Yeah, I did. So elevation. Okay, so find the angle of elevation. So if you remember what an angle of elevation is, so basically it's, this is the ladder, here's the ladder, and here is the wall. So from here to the tip of the ladder, that guy is gonna be what is 37 feet. The ladder itself is 65 feet. And then you're finding the angle of elevation. So the angle that's from the ladder to the ground. So if we say this is the ground, this is going to be the angle of elevation, the theta. Okay, so now all we have to do is find out what this is going to be. So how can I relate theta with these two angles? Well, this just forms a right triangle. So this is just the opposite over the hypotenuse. So you're going to have sine of theta is equal to the opposite over the hypotenuse. Okay, so how do I find the angle of theta? Well, one way that you can do is just take sine inverse, because that's going to basically cancel out the sine. So by applying a sine inverse, or arc sine, whatever you want to do, that's going to cancel this guy. So theta is going to be equal to the sine inverse of 37 over 65. Now at this point, you might want to consider using a calculator. Make sure it's set in degrees. So we're going to press the sine button twice. So you get sine inverse. Then you're going to get 37 over 65. And that's going to give me, since I want one decimal place, about 34.7 degrees. Okay, and that's going to be my angle. Okay. So we can use sine inverses to be able to find the angles of elevation of depression too. This is basically how you would solve this basic problem. And we will be doing more of these different word problems later on when we get to non-right triangles. So this is just how you would find a little bit of sine inverse, cosine inverse, and tangent inverse.